The last pattern in this module is accumulate, then process, also known as queuing. Accumulate, then process is a mechanism by which guaranteed delivery of messages can be implemented. In this method, Boomi persists the messages sent by the source system or pulled from the source system either in a queue or on disk. The messages are persisted immediately upon receipt before any further processing occurs in the integration process. This allows the message to be reprocessed if a failure were to occur during processing and/or during transmitting to the final destination. We often get asked about how to implement this pattern because users are concerned about assuring message delivery with an asynchronous scenario, or problems occur in the process or with the end system. So here is an example. Patient test results can be stored, attached to a health record, and forwarded to a provider system when it can be reached. This illustration is a solution diagram. It starts with a source application where it sends a message to a Boomi process endpoint. The Boomi process persists the message in a data store, a queue or a database, and returns acknowledgement to the sending source application. Another Boomi process runs periodically and periodically reads the data store and attempts to send messages to a target system. On failure, the Boomi process retries the message send. Here are a few design considerations. You want to select the right mechanism for storage. This is message queue, disk, or database. When you are dealing with large volumes of messages, disk and database overhead tends to build up. Message queues are almost always a better option as they were designed for messaging. If you are using a database, you have to handle the get and delete operation of the message explicitly as part of the process design. There are a couple of errors to consider and some recovery handling procedures. There could be an error of persisting to the data store, in which case the sender has to resend. The sender recognizes failure since acknowledgement is not received. Another error is while sending to the target system. The messaging system has to retry until the delivery is confirmed. It's important to note that a message can go through multiple iterations of store and forward before it reaches the target system. So you must consider if there are any critical retry points that can't be redone. Also, you need to handle failures, retry, stage, and subsequent retry processes. For this pattern, we are going to have two processes. The first process has a web service listener listening for incoming requests in box 1. In box 2, incoming requests are persisted to a data store. It's a local disk in this example, but could be an Atom queue, Amazon storage, local database, or another messaging queue service. The second process is pulling the data from the store by 1. Reading periodically with this process. 2. The source format is transformed to target format. In this example, it is XML to database. In box 3, you can see a try-catch block is inserted to trap errors. Delivery is attempted a defined number of times, in this example 3 times. In step 4, sub-process calls to insert data into a database. And in step 5, errored messages are stored to a data store, in this example a local disk.